kinetic energy, the energy of motion. So let's consider a box sitting on a frictionless surface, and if we apply a horizontal force to a box, so that's a hand there, it's applying a force, a normal force, as you recall, that box accelerates. And when that force is no longer being applied, the box will continue to travel at the same speed forevermore, as long as there aren't any forces acting on it. Okay, so there's a box of mass m and speed v. So even though the box is no longer experiencing a force, its motion has changed. It's different to what it was before. It's gone from being stationary to moving with a constant velocity. Now, when the box is in motion, it can do things that it couldn't do before when it was stationary. For example, it could collide with another object and exert a force on it. It can do this because it has energy due to its motion, or kinetic energy. Kinetic comes from the Greek word kinetikos, which means motion. Okay, so physicists were able to show, and you can do this as well, theoretically or empirically, so through experiment, show that the amount of kinetic energy due to an object's motion is proportional to its mass, and it's also proportional to the square of its speed. So here's our equation for energy. One important thing to note about kinetic energy, symbol EK here, is that it's a scalar quantity. Now, a scalar quantity is one that only has magnitude, it doesn't have a direction. So what this means is that it doesn't matter which way an object is moving, it's still going to have the same ability to produce change, the ability to exert a force or do stuff, no matter which direction it's travelling. The next interesting thing to point out is its units. Now, the units of energy are joules, but if you look at the rest of that equation and say, well, what's the units of mass and what are the units of velocity squared, you can see that joules, the equivalent unit for joules, is kilograms meters squared per second squared. And we'll keep looking at the units of energy as we look at different types of or different storage modes of energy. The next point that I want to make is that kinetic energy depends on the velocity. Now, this is not all that surprising. What is interesting though is that it depends on the square of the velocity. So if we double the velocity, if we went from a velocity of v, or a speed of v, to 2v, then it doesn't just double. So if we doubled our velocity, it doesn't just double the kinetic energy, it actually increases it by a factor of 2 squared, which is a factor of 4. So our kinetic energy would quadruple. And the last point that I want to make here is that, of course, the kinetic energy, or the ability of it to produce change, also depends on its mass, which I've just noted here. And just to highlight that, it's obvious that if you threw a bowling ball at something, then it would produce more change, or would have more of an effect than if you threw a ping pong ball. So it would hurt more if you want to think about energy being pain. So that's kinetic energy.